Okay, so 7-5 day 3. And it's airspeed plus wind equals ground speed. We're going to do, I believe, 3 of those. And just remember, air speed plus wind equals ground speed. And wind always has to get fixed. Direction must be fixed by adding 180 or ground speed. I want it to be a D. Subtract 180. Okay, I'll let you get that down.
Does that work with the angles then too? Or
With the what?
the angle?
We're adding it to the angle.
I'm saying for wind speed, or for airspeed.
No, wind is the only one. Because when on a
I'm saying like to find like the bearing.
find the bearing of the wind,
Yeah.
they won't ask you that. It's always going to be about the ground speed or the airspeed. Are you ready? All right, a plane is heading due south with airspeed 206. So plane headed due south at 206 miles per hour. A wind from 56 degrees at 8 miles per hour. Can you find the bearing and ground speed of the plane? I highly recommend you write the 3 vectors off to the side and tell me the information you know about them, because I give you points for that. So we've got airspeed, wind, and ground speed. Okay. Do you know which vector this due south and the 206 miles per hour goes to? Okay, I got air and I got ground. Which one is it? Why is it not ground speed? Because that's what they're asking you for. It says find the ground speed. Yep. That's how you can tell. So it's not ground speed, so this has to be the airspeed vector. So it's south and 206. Wind is easy to pick out. 8 miles per hour, but 56 degrees. Wind always has to get fixed. How are we going to fix the 56 degrees?
We can add 180.
Add 180 to it. So 56 plus 180 to 36. So it's blowing from the 56 degrees. It means it's going to push it in the direction of 236 degrees. And we want both things about the ground speed vector, how fast it's going and its direction. We don't know either one of those. Now it should be okay. So it's airspeed plus wind equals ground speed. Here we go. You guys like to start usually with airspeed, so we'll go there. It's south, so I don't really need my north line yet. So south, 206. Okay, we're going to add on the wind. I have to add it on starting from
The north line.
the arrowhead and then a north line.
So,
Where's my north line going to be?
So,
Right on top of my airplane vector. So I'll just kind of show it off to the side here. There's my north line. How much do I rotate?
236.
Oh yeah, down here. So 2, so there's 180. About here. There's my wind. So that was 236 degrees. 8 is the speed. Any questions so far? Now we draw in the resultant, which is the ground speed vector. That's going to start here at the beginning, finish here at the end of the wind. This is ground speed, which we know is the resultant. So if I look at my labels, I have called that speed, the length of that side is my speed, I've called that x. That's one thing I want to know. And the other one is the direction, the bearing of that red vector. So how would I show the bearing of that in my picture? I need my north line. I need to know how far clockwise from north that red vector is. So to answer the question, I need to know that angle measure, which I called y degrees. So far, so good. Okay. We've got two sides on the triangle. What angle can we find rather easily?
The angle in between them, you can do 360 minus 236.
Yes, you can see this angle didn't get chopped up. I can find this angle right here by doing what Lexi just said. 360 minus the 236. It's 134?
124.
124. Now you can run a nice SAS program and then find the two answers to the question. So I want you to look at what comes up, look at what you were trying to find, see if you can get them on your own. Should be a very small angle. Very, very small.
It's 1.8, but then what you added to the 180.
Mm-hmm.
do you have to type a certain thing in the calculator first?
Nope, not on SAS. Doesn't matter which side comes first.
Why is it wrong?
Well, you got to put a side for a side, though. You can't throw an angle in there. You didn't get 1.8 degrees up there?
Yeah,
Oh.
when you added 180.
Because I need to know how far from north. I need this angle. I only know from here to here is 1.8. What do I have to add on to get from the north all the way to that?
180.
180. It's the 180 up to the south line. So the y is 180 plus the 1.8. So you can say 180, 1.8. Might be 182 in the book. How fast was it going?
211.
So 211.
211.
I see 3 sig figs here. Any questions on that one? That's pretty straightforward, like I would have on the test.
Not with me.
That's as straightforward as they get. These next two are going to be a little...
No, but I'm saying
Little
the
twist.
calculator for you.
Oh, you didn't get these answers?
No, you got a different answer too.
Okay. well,
Did you? Are you in degree mode on your new calculator?
No, he's in. Oh.
No.
That would be the problem.
Oh.
So we'll make sure he's going to get some good answers here. You're good? Okay. All right, next one.
Okay, the direction is what? And then it's
181.8. All right, number 2 is number 18. Do you want me to write the information out, or do you want to look in the book?
Write that out.
Okay, write it out. Okay, 18. It says, a pilot flying at 168 miles per hour. So flying at 168 miles per hour. She wants her flight path to be on a bearing. So wants to be on a 57.6 degree bearing. We have a south wind that's blowing at 27.1 miles per hour.
That's like really hard, isn't it?
Yeah, that's a strong wind. Find the bearing the pilot should fly.
Do they actually do bearings and stuff like?
Oh, absolutely. That's their directions, yes. If you're on a boat, captain of a boat or a plane, you will deal in all bearings, what direction you're going in.
Hey, Schwartz, what page is this on?
I have no idea. The same section we were on yesterday. I'm in the back of my book. Let's see. Find the bearing the pilot should fly and the plane's ground speed.
Let's list them.
Let's list them. All right, so we've got airspeed vector, wind, and ground speed vector.
Airspeed.
Okay, flying at 168 miles per hour. What do you think that is? Airspeed or ground speed?
Airspeed.
It is airspeed. How do you know it's not ground speed?
You're looking for them.
Because you're looking for ground speed. So the 168. Do I know what direction?
57.6 degrees?
No.
That's what it wants.
That's what it wants to be on. So what is this 57.6 attached to?
The
Ground
27.1.
That's the ground speed vector. Wants to be on that.
You guys said we didn't know that.
The actual ground speed we don't know. So remember, there's two things about a vector. There's its speed and its direction. I know half of the information about the airspeed, and I know half of the information about the ground speed. So they gave me half of each one. But the wind, they always give you both things about the wind. We've got a south wind, which has to get fixed. That's where it's blowing from. And at 27.1 miles per hour.
Actually going north.
So it's actually going to go north when we draw it. So we want to draw this north. Okay, this one's a bit of a challenge because usually we know both pieces of information about the airspeed vector and both pieces about the wind. I only know one piece of information about the airspeed vector. So I really can't start with this 168 miles per hour because I have no idea what direction to draw it in. But what vector can I start with?
The wind.
I can start with the wind. Let's start with the wind. What direction do I know the wind is going in?
North.
North. And 27.1. Okay. I cannot attach the airspeed yet to this because, again, I still have no idea what direction the airspeed is going in. Do you agree with that? Nothing here tells me what direction to draw this one in. But I can draw the ground speed vector. But where is the ground speed vector in reference to the starting wind vector?
57.6 degrees.
Yep, but where would I draw it at? Do I draw it at the arrowhead or do I draw it at the tail?
I feel like the tail.
Yes, because it's the resultant that I'm drawing in,
What are we drawing?
the ground speed. So I'm going to draw in the ground speed vector, and I'm going to make it red because I've been doing all my resultants in red. So from the north, I'm going to swing over 57.6 degrees. And here's my ground speed vector. I don't know how long it is. I'm just going to make it long because it's usually a big vector. That's my ground speed. I'm going to move my 27.1 to the other side, so I don't think it's an angle. I do know that this angle in here is 57.6 degrees. Sorry, that got slopped in there.
And then you can
Can I draw my airspeed vector now?
yeah.
Yes. So at the arrowhead of this,
Why can you draw it now?
because I know it's got to end over here. It gets attached to the arrowhead of the wind, and I know it's got to end at the end of the resultant. It's my airspeed vector. And I do know how fast it is, 168.
Is there even a program for
Hmm.
side angles?
No, there is not. Okay, let's see what we want to know, though. We want to know the actual ground speed, so I want this side. This is the resultant. And I want the direction that the pilot should fly. That direction is a bearing from the north. I need to know that. All right, so Kenley's already ahead of us. She looked. It's
Don't we already know the bearing the pilot's flying on?
no, we only know the speed. We know after the wind has pushed it,
Oh, you want the air.
where does she have to head the plane so that the wind pushes her onto that spot she wants to be at? That's what we're looking for. So this is an angle, side, side. Angle, side, side, which we didn't write because I said it was only going to come up a couple of times. But what we can do is do law of sines and go set up our proportions.
168 over the sine of 57.
168 over the sine of 57.6 equals 27.1. Is that the one I can find? Oh yeah, over sine of, I'm going to find this down here. If I throw a letter down here, A. Once we get that angle, then we'll be able to run a program. So do your cross multiply, divide. Inverse sine. Go 3 sig figs.
7.83 degrees.
7.83.
Yep.
Are you good with the 7.83?
Yep.
All right, 7.83 degrees. Now you can run angle. Oh, you got lots. Angle, angle side, or angle, angle, angle side. You got two, it doesn't matter. Angle, angle side. Pick which side you want to use. Do you want to use the 27.1 or do you want to use the 168? Doesn't matter, but it's going to matter what angle you put in first. So which side would you like to use? You guys pick. 168. So if I choose the side to be the 168, what angle do you have to put in first?
57.6.
The 57.6. The angle across from the side you're choosing to use is the 57.6. And then the other angle is at 7.83.
So you're using which program?
Angle side.
And you're only using those three?
Yep.
Angle across the side.
If we choose to use the 168, the angle across from the side is this one.
Yep.
If
And
you
it
had
says angle included. I don't know that.
angle included, what program do you have?
AAS.
It's got to be the other one. Try the 7.83. See what you get.
What do you mean try it? It's still gonna say angle included.
Are you sure you didn't type SAS? Get out of that program. I don't think you picked the right program. I disbelieve you. Angle side.
Angle side.
Okay.
AAS.
Very good. Enter.
Enter. Angle across side.
57.6.
57.6. Angle included.
7.83.
That's not included.
I don't know why it says that. Type it in. See if it works.
Side.
168.
Go.
What did you guys get for that other side?
114.7.
Got 180.
No, 180 is the
Couldn't see one.
180 is the side.
This is the ground speed's 180?
181.
181.
Okay.
And then what about the angle up here?
114.
Inside is 114.7.
Yeah.
Okay, now what do we do to that to answer the question?
Subtract from 180.
Subtract from 180.
Oh my gosh.
What?
Yeah, it's 0.57, it's not 0.7.
Oh, so 0.6. So 180 minus that 114.6 will be your direction. Okay, nice job. One more together.
Hold on.
Mm-hmm.
But we found
We found the two things, how fast the plane is actually going with the wind pushing it, 181, and then the direction was whatever that came out.
Alright.
All right. The last one is number 19. I'm not a calculator, I don't know. Number 19. What? Bearing and airspeed are required to fly 400 miles due north in 2 hours.
When do we switch this back?
Oh, 2.5 hours. 2.5 hours. If wind blows 11 miles per hour from 328 degrees. Airspeed, wind, ground speed. Okay, they weren't really nice to us on this one. But this flying 400 miles due north in 2.5 hours. First of all, what vector is that?
Ground speed.
And why did you pick ground speed?
Because we know that.
Because it's asking for airspeed. So I know it's not the airspeed stuff. So, due north, 400 miles in 2.5 hours. What can I do with those two pieces of information to get something useful?
Divide 400 by 2.5.
Yep, you want miles per hour. So if we take 400 and divide by 2.5, how fast?
160.
160 miles per hour. So they tried to be tricky and not give you the speed. So what we're looking for is how fast does the plane engine speed have to be so that after the wind is pushing it, I end up at this speed and in this direction. And what do we know about the wind?
Flows.
11 miles per hour. From 328, which must get fixed. How am I going to fix the 328?
Subtract 180.
So 328.
148.
And this time I know nothing about the airspeed vector. It wants the direction, the bearing, and how fast it's going. I just choose to call them X and Y. What bearing and airspeed are required? The actual speed, airspeed. Okay, and remember, it's these airspeed and wind that get added together to equal the ground speed. The only problem is I'm not going to be able to draw in the airspeed first. So which one should I start with?
Ground speed.
I'm going to start with wind.
Okay.
Okay, so wind.
Why would you not start with
Because I like to draw one of the two that I'm adding together first, and then that's the equals. I think it's easier to start with something you're adding, because then you know where to start the ground speed at. So, wind first, 148 degrees, so give me your north line. Show me 148 rotation. And this is wind, so keep it short. Okay. On the arrowhead of this is going to be my airspeed vector, but I don't know anything about the airspeed vector. But I do know something about the ground speed. Where should the ground speed get attached to this wind vector at?
Tail.
At the tail. The ground speed gets attached to the tail. Okay? So here's my resultant, my ground speed. What direction is it going? North.
when does the north move, like is that air when it changes? You know, like if it's north, it goes north.
Wind. Wind is the only thing that does that. Wind only.
Okay, so why is it attached to the tail?
Because when it's always airspeed, air plus wind, and these two can be switched, but they're always head to tail, and then that equals ground speed. So even if this was wind and this was air, whatever vector I draw first, either airspeed or wind, the ground speed is attached to its tail, because the ground speed is whatever I start with to wherever the second one ends. So I started with wind. I don't know where to draw the airspeed, but I know the ground speed is attached to the tail of the first vector, always. So first vector and ground speed are always tail to tail. So now when I draw in my airspeed vector, airspeed is attached to the wind. Where is it attached to? The tail or the head? The head. So there is airspeed. I'll use little a for airspeed.
Can we run SAS?
You can run SAS right now. We're trying to find two things. One's going to be super easy. The speed of the plane is going to be easy. The direction that it's going in is going to be a little bit of work. So what are you coming up with for the speed? 169 is, they got a 170 to 2 sig figs. Okay, now the tough part of the problem. That was the easy part, just so you know. The question is, what direction is that? And a direction comes from from where?
North line.
So north. I need to know all the way around to that. That's my direction. It's almost going due north. It's almost at 360 degrees. Not quite.
Do alternate interior.
Alternate interior. How's alternate interior going to help me?
You can subtract the 148 from 180.
Oh. That would work. You could do there's an easier alternate interior in this picture. This angle at the top
Yeah, and you switch it over.
is alternate interior with this piece here. That would be, your way would work, Alyssa, if you worked over here. It'd just take a few more steps. Where this, there's only one, after I know this angle, what do I do to get this?
Subtract from 360.
Subtract from 360. So what,
It's 2.0.
2? So 360 minus 2, 358 degrees. Okay, what ones do I have for you to try? I thought you'd have more time today. Page 317. Four of them.